Hello there, we're going to look again at differentiating implicit functions, exercise 10D, the second part of it. We certainly saw a few of these last time, I'm going to do a bit more. So the starter says, given that this equation is true, and you notice it is written implicitly, i.e. it doesn't say y equals, it says a mixture of stuff. Find an expression for y by the x. So we kind of looked at this last time. Now, unfortunately, your calculators can't type these in, and you can't write them. Your calculators expect the functions to be written explicitly, y equals. So on that basis, I've drawn this one for you. It's quite a nice function. You can see, a bit weird, but there you go. That's the function. So given this is true, first of all, spot this. I did say last time that you often get products. This is a product. Look out for them, expect them, because lots of people forget about them. And they get these questions wrong because they don't spot the product. And on that product, I'm going to write u equals the first bit, 2x squared. And I'm going to write v equals y. U dash, therefore, is, well, 4x. Nice. And v dash is 1, but write dy by dx because it's the wrong letter. And you might as well just call that dy by dx. So given that, it's now going to be multiplied on the diagonals, and you should remember it is uv dash plus vu dash. I'm going to differentiate this then. So I'm going to get 2x squared times dy by dx plus on the other diagonal it's 4xy. Now, that's the first bit differentiated. Now the 6y squared, but that will give me 12y, but it's the wrong letter, so I'll write dy by dx. Minus 8x squared is minus 16x. Equals 2, that gives you 0. I did say very often it's a number on the other side which disappears. Take out dy by dx as a common factor. On this side I'll get 2x squared plus 12y. And at the same time, I'm going to move that onto the other side and move that onto the other side. I'm going to get 16x minus 4xy. So you can just do it in one step like that. And what do I now need to do? Well, I now need to divide that bracket. So I get 16x minus 4xy. And you could probably tidy this up a bit, actually. If I divide everything by 2, that will work as well. So that's 8x. Minus 2xy over x squared plus 6y. There you go, that's me done. Hence find the gradient of the curve at 5, 3. Now obviously that's x. I'm looking where 5, 3 is. 5, 3 is actually that point up there, isn't it? So it looks quite a small number, but I'll find it. The gradient at that point will be, well, it says 8x. So that's 8 times 5. Minus 2 times 5 times 3 all over x squared, 5 squared plus 6 times 3. So what is that? 40. That's minus 30. I get 10 on the top. On the bottom I get 25 plus 18. I reckon that's 43. 10 over 43 is, I've got an answer for this. 10 over 43 is right. So the next question then, it says we've got some equation written implicitly, as you can see. It wants me to find an equation connecting these three things. Okay, let's just do that straight away. Let's differentiate that. If I differentiate that, I'll get 6x plus 2y dy by the x, because it's the wrong letter, is equal to, there's my product. I keep on telling you to look out for the product. Do that over here. U is 2x, v therefore is y, u dash is 2, v dash is 1, but the letter's wrong, so it's dy by the x. So I'm just going to call that dy by the x. So when I put this in, it will be that and that. So it will give me 2x dy by the x plus 2y. Now I need to differentiate the 8x, which is 8, and 2 disappears. So that's my expression. I'm going to tidy it up. I don't like that. So I'm going to write dy by dx, and I'm going to put all these things on the left. So I've got 2y here, but then the 2x moves over, becomes a minus dy by dx, and as I factorise it, gives me that. I've got 2y plus 8 minus the 6x, and therefore dy by dx can be written as 2y plus 8 minus 6x over 2y minus 2x. And again, I think I can divide everything by 2. That will give me y plus 4 minus 3x divided by y minus x. Hence show that the coordinates of the points on the curve at which dy by dx equals 2 satisfy this equation. Well, it's telling me to set that thing equal to 2, so I will. Y plus 4 minus 3x over y minus x equals 2. It says dy by dx is 2. Yep. Now, this is a divide, so move it over to the other side and become a multiply. So multiply both those, I get 2y minus 2x. Put all the y's and x's on one side and all the numbers on the others. Now actually I've got the 4 there already, so I'll move the y over there, I'll get y, move the 3x over, that will give me x, and that will give me 4. It does work, therefore x plus y equals 4. Done. And that was meant to be my differentiation, which was this one, yeah, a long time ago. Find the stationary points on this curve. And of course, stationary points occur when you get dy by dx equals 0. So it's another way of saying differentiate it, please. So let's go for it. 3y squared. Wrong letter, so I better write dy by dx. And sure enough, there was my product. So I'm going to write it up here. U equals 3x. V equals y squared. U dash equals 3, v dash equals 2y dy by dx. Wrong letter, so I need to dy by dx. Multiply on the diagonals. So plus, what have we got? We've got 3 times 2y, so that's 6xy dy by dx. Plus 3y squared minus x cubed. Oh, sorry, I've got to differentiate. You got it wrong there. 3x squared. And when I differentiate 27, I get 0. So if I take out dy by dx as a common factor, I'll get 3y squared plus 6xy there. And I'm going to move these things over to the other side at the same time, and that will give me, I think, 3x squared minus 3y squared. Obviously, divide by the bracket, dy by dx equals 3x squared minus 3y squared over 3y squared plus 6xy. And of course, this has to equal 0. That's what we said earlier on. There it is. This equals 0. dy by dx is 0. So that equals 0. Now, the great thing about this, if you get a fraction equal to 0, you can move the bottom over, times it by 0, and it's still a 0. So effectively, I get 3x squared minus 3y squared is 0. Or, because I can divide by 3, I get x squared minus y squared equals 0. Now, the temptation here is we think, well, x must equal y, and it probably does. But notice there's also x plus y, x minus y here as solutions. And you'll notice, by the way, I've put up the graph here as well, and I'm hoping for, see, I think there's a couple of solutions. It looks there as if that was at 2, 2. It looks like 2, 2, but you can never be sure. God knows what this is. It looks like there. Is that 3, minus 3? That's what it looks like, but you can never be too sure, so you just got to be a bit careful. Now, one thing I know is that either this is 0 or this is 0. So either x equals from there minus y, or x equals y. Now, on the face of it, this hasn't told us very much. It's told us a little bit. It's told us the numbers need to be roughly the same. So that fits in with my answers here. But I don't know what values of x it is. You know, from the picture I can see it, but I can't really see it anywhere else. But what this allows me to do, if x equals minus y, I am not finished yet, because I could go back to the original equation. So let's go with that. X equals minus y. That's what I wrote down. Remember, that's from the difference of 2 squares. And if that's true, then I've got y cubed. So let's go with y cubed plus 3x. Oh right, x is minus y, so I reckon that's minus 3 times by y squared minus 3y cubed. Minus, now it says x cubed. Now x cubed would be minus y cubed. But it's a minus, I think that's plus or y cubed. That's getting complicated. That equals 27. How many y's are 2? I think it's minus y cubed equals 27. So y would be equal to minus 3 if you do that. Oh, that's that point there. And of course x is minus y, so x would be equal to 3. So that point is actually right. I like that. I didn't know which point it was going to get me, but there you go. And the second point says x equals y. So let's do exactly the same thing, but now with x equals y, and I sub x into this, and x is equal to y. So wherever I get an x, I'll write a y. So it says y cubed again, plus 3x. This is easier. 3, rather than x, I'll write y. So that's y cubed minus a y cubed equals 27. Y cubed minus y cubed disappears. That gives me 3y cubed equals 27. Oh, that gives me y cubed equals 9. Oh, right, it's not what I thought it was going to be. Y then is the cube root of 9. Because x is equal to y, x is the cube root of 9. The cube root of 9, just do it on my calculator, 2.08. So it was very close, but it wasn't quite right over there. It was turned out to be cube root of 9. And that's what it actually says. It's a cube root of 9, comma cube root of 9, and 3, comma minus 3. So that was a bit of a surprise, really. And this last one, show that this is true using implicit differentiation. It says, given that y equals 2 to the x, differentiate that. I remember this actually. There's a little trick here. You can't do it in its form like this, because, well, for a start, it's not implicit differentiation. It's stated explicitly. But if I take logs of both sides, I get log y equals log of 2 to the x. And that allows me to bring my x down and I'll get rid of my problem. I get log y equals x log 2. It's the power law. Now I can differentiate this implicitly, because it doesn't now say y equals, it says log y equals. So if I differentiate log y, I get 1 over y, but I need to write dy by dx, because the letter is wrong. Now this is, on the face of it, it looks as if it's a product rule, but it actually isn't a product rule, it's just x times some number. So if I differentiate 8x, the answer would be 8. So if I differentiate effectively log 2 of x, the answer is log 2. Now move the 1 on the other side, dy by dx equals y log 2. Don't like y there. Y is equal to 2x, 2 to the x, sorry. So this implies that dy by dx equals 2 to the x log 2, which of course is what it said I needed to show. So I've done it. Look, we've come to the end of exercise D.2. We're going to go back to these questions. I don't know why I said question 4. I think we'll just be finishing off all the questions we haven't yet done. So thank you very much.